Hello, everyone, and welcome to today's webinar, Delivering Excellence with Microservices on AWS. My name is Carmen Puccio, and I'm joined here with Mike Deck of AWS, and I'll be your speaker and moderator for today's webinar. So we're just going to cover the agenda quickly, and we're going to get right into it. Brief introduction on myself. Again, my name is Carmen Puccio. I'm a Principal Solutions Architect here within the AWS partner team, focusing on containers and working with our container partners to help move workloads over to AWS and optimize that experience. And I'm also joined by Mike Deck, who is also a Principal Solutions Architect who works in the serverless space in a very similar capacity, helping our customers build and adopt serverless technologies. What we're going to talk about today is microservices, and we're going to go down the wormhole of essentially explaining what microservices are, the comparison between your traditional monolithic workloads and how they compare to microservices today, the benefits around them, and then we're going to get into the best practices on how you're going to adopt those as part of your organization and how you can essentially pick and choose some of the AWS components and services to help build that next generation development platform. At the end, then we're going to get into the Q&A, like I said earlier. So if you have any questions, feel free to just type those right into the panel and we'll get to them at the end. So let's get started. So with that said, we'll get into this quick view of essentially what a microservices is, right? So by definition, they're an architectural and organizational approach to software development, where software is composed of all of these small independent services that communicate over essentially a well-defined API, right? And we're going to talk about the benefits and techniques around building microservices as part of this webinar, but at the highest level, you have to remember that microservices are considered to be autonomous, right? So meaning each component and each service in a microservices architecture should be deployed, developed, operated, scaled without essentially affecting all of the surrounding and other functioning services that are part of the microservices mesh. So services shouldn't share any code or any implementation with those other services, and all of the communication between the microservices themselves should be done over these well-defined APIs. And they should also be considered specialized, meaning each service is designed for a specific set of capabilities and focuses on solving a particular problem. So if your development teams contribute more code to a service over time, and this service becomes more and more complex, you can think of it as that you could essentially break that out into smaller services or smaller microservices. It's important to think about when you're building these microservices that not only that there are these independent services, but those same services are also owned by these small self-contained teams, and we call those pizza teams. We spoke extensively in our previous webinar, Creating a Modern Development Culture with AWS, around the concept of pizza teams in your organization. So if you want to learn more, go check those out. They'll be on demand very, very shortly. We just did them last week. So with that said, I just want to talk about the new normal, right? When we talk about microservices, we talk about modern application development, we're talking about this new normal, meaning more and more companies are increasingly global and the products are becoming digital. Cloud, mobile, big data, social technologies, they've impacted application development, but these digital disruptions are forcing change at an even faster rate. So this new normal means that application leaders must essentially, insert a digital DNA into their culture, their processes, the technologies to transform themselves into these top performing organizations. So they need rapid innovation, and microservices architectures essentially make applications easier to scale, faster to develop, enabling this innovation and accelerating time to market for your new features for your customers. So we covered this slide in the last webinar as well, and this is our innovation flywheel, right? So essentially what we're saying is experimentation leads to innovation. It's okay to fail because you can quickly learn from your mistakes. But this time around, I want to talk about it in the context of a microservices. So traditionally, organizations architected, their IT environments into these, large monolithic entries, right? They built these monolithic applications inside their data centers, and the idea was essentially to make them too big to fail. But the problem is preventing failure is very, very tough, right? It's almost impossible. And if you think about it, moreover, like the way that they built these entities, they're not really conducive to agility. They're not necessarily cost effective. And as a result, organizations are starting to look in a different direction, and they are leveraging microservices. So the fact that microservices are modular means that if you do them right, you gain speed and flexibility, helping solve many of the problems that you created with those legacy monolithic apps. So again, we're still talking about innovation and experimentation like the last webinar, but the point I want to stress here is it's easier to make a lot of small changes rather than that one big massive one that came with monolithic architecture. So for microservices, you can iterate on each one independently to deliver at essentially whatever pace you choose. So, the thing to remember here as well is failed experiments are less expensive, right? You want to make it as easy as possible for your development teams to essentially take part of this innovation flywheel and learn from their mistakes, feed into ideas and experiment. And, if you do fail, that's okay, because you can always try again, right? So with that said, one of the things that people have a question about, and I'm going to pass this over to Mike, is like, where should I start? Which services am I responsible for? And they have questions around the responsibility model. So I'm going to let Mike go into detail around this.
Yeah, great. Thanks, Carmen. So I think, speaking within the context of this idea that, hey, what our real goal here is in adopting microservices is fundamentally we're trying to figure out how we can move faster. And so in order to do that, the two big key areas to focus on are how do we decrease sort of the activation energy necessary in order to run an experiment? So how do we make it easier to build things and get things up and running quickly? And then also, how do we sort of reduce the cost of failure, reduce the cost that it takes to shift and pivot and change direction based on customer feedback that we get? And so the way that we oftentimes think about this, and the way that we work with customers to think about what underlying services make sense for them to adopt when they're moving into this new direction, is to look at it from the perspective of who's responsible for the operational aspects of the infrastructure that you're running. So when you look at this chart, think about it as a continuum. So at every level, every service that AWS offers, there's some amount of operational overhead and security and reliability that is incumbent upon AWS as the cloud provider. And then there's another portion that's incumbent upon you as the customer. So we refer to this as the shared responsibility model. And the way that you can think about our services is that there's this continuum that you can slide down or up depending on how much total control and responsibility you want to take on for yourself. But basically, the idea here is that as you move to the right of this chart, as you offload more and more of that responsibility onto the cloud provider, AWS in this case, the less that your teams are having to deal with things like patching operating systems or managing runtimes and dealing with kind of the day-to-day undifferentiated heavy lifting, and the more that you can focus on building differentiated business value. And that's really kind of the underlying key of building microservices, is getting as much time and energy focused on building those, building what's differentiating about your business, instead of managing all of the underlying infrastructure is really kind of the key. So taking that to its sort of logical next step, that is where we start to talk about the serverless services that we have within AWS. So when we take a look at this set of services, these are the ones that kind of fall at the far right-hand side of that scale. And what's important to note here is that there's a wide variety of services across a number of different domains that you need to be thinking about when you're designing a microservices architecture. So, oftentimes customers think about, just deploying everything that they have on top of VMs running inside of EC2 and managing all of the different components of their application. But what we see is the customers that are most successful and who are able to move most quickly are leveraging a wide variety of services across a number of different domains. So in addition to compute services where you're running your own code, also using things like managed databases or managed orchestration layers or API services, et cetera, in order to offload more and more of those kind of standard undifferentiated tasks off of your plate and put them onto ours is really a helpful strategy to adopt in order to be successful as you're building and architecting these types of microservices designs. So if we go ahead and take a look at just that compute layer to start with, I think this is one of the areas where customers are particularly interested to get some level of guidance around how they get started when using microservices. So there are a couple of different options, and really looking at these services as the place where you're going to run your code. When you look at it from a serverless perspective, you can think about it in terms of either a function-oriented architecture. So AWS Lambda provides a functions as a service. You do nothing more than provide your code and some configuration about the events that you want to trigger that code. And then the platform itself is then responsible for managing everything else beyond that. There are a few limitations on this in terms of kind of the amount of time that you can spend executing each function. Can't be longer than 15 minutes. And there are certain other cases where, for instance, if you've got existing legacy code that was written to be run on top of a VM or a server, or expects some other some underlying aspects of the hardware to be present, you may not be able to use a functional model. And so in those cases, you can use a full-fledged container running on top of AWS Fargate. So this basically allows you to treat containers as first-class citizens within the AWS service ecosystem, and manages all of the underlying infrastructure for you. So you no longer have to think about the underlying virtualization layer, and you're able to run containers, run your microservices that are based on those technologies without having to deal with any of those additional operational concerns. Now, in some cases, this may not be a good fit for the services or infrastructure that you're running. There may be cases when you actually need more control. You want to move further left on that operational model that we talked about, because you need finer grain control or have other kind of business requirements that are required there. So for that, we've got a number of other services that I'll let Carmen discuss for running more traditional kind of containerized workloads.
Yeah, awesome. So essentially, if you think about it this way, we have customers running containers on AWS for that fitting multiple use cases, right? It's not just microservices. We'll probably talk about this a little bit more as the webinar progresses. But I came from the mass migration team. One of the things that we saw was essentially customers starting to pick up their legacy applications and move them to containers to essentially achieve a level of agility that they've never seen before inside of their own data centers, right? So it's not just like, hey, I want to build microservices using containers. There's many more use cases. And I think another thing to drill home here, and a little bit came out in the prior slide, is when we see customers taking advantage of microservices, it's not containers versus serverless. It's usually a mix, right? As customers evolve and they understand the various different use cases around their application and how they can meet the needs of their business, they'll leverage one or the other, or usually it's a combination of both, right? But when it comes to building containers on top of AWS, we have a couple of different services, and I just wanted to highlight them really quickly. Everyone's essentially hopefully familiar with the Elastic Container Service, or ECS, and it was announced, I think, as far back now as 2014. But what ECS is it allows customers to deploy, manage, and scale their container workloads without having to install or operate the container management software. It's built with deep integrations around the rest of the AWS platform. So including things like services like load balancing or security, permissions management, maybe it's networking or storage, monitoring. Regardless, it's built for high availability and low latency and high throughput. And this allows ECS to be one of the fastest growing startups and largest enterprises in the world to run tens of millions of applications worldwide, right? And then, I think it was in 2015, we released the ECR, or the Docker Image Registry, called the Elastic Container Registry. And our goal here with the ECR was to enable developers to use the same Docker push-pull APIs to store their images. And we see this product being highly adopted by our customers, both running containers on AWS and really across any environment. And what we see is the ECR powers them to run an incredible number of workloads across cloud or on-prem. And then I think it was in 2017, we announced Fargate, which is a compute engine for ECS that allows you to run containers without having to manage the servers or clusters. So if you think about the old ECS model that I was talking about before, you're responsible for running your nodes, right? While the backplane is managed by us. In this case, with Fargate, you no longer have to provision, configure, or scale those clusters to run your containers. This removes that need to choose server types when you're going to scale your clusters, or thinking about things like cluster packing, right? Fargate takes that, and removes that need for you to think about that level of operational responsibility, and you focus on developing and building your applications instead of managing all of that infrastructure. And then finally, in 2017, we announced the Amazon Elastic Container Service for Kubernetes. And hopefully, you've heard about Kubernetes. It's wildly popular, but it's essentially it's a managed service that allows you to run Kubernetes on AWS without having to install or operate your own Kubernetes clusters. And what we consistently heard from customers is that while they like to run Kubernetes because it is highly available, scalable, and cost effective, the hard part is the management and the scaling and maintaining Kubernetes cluster nodes, right? It's a tremendous hassle. So customers asked us if we could do it for them, and EKS was just that, right? It's built from unmodified upstream Kubernetes, and it allows you to use existing features, plugins, tooling that you may have built for your own clusters, and applications running inside of existing Kubernetes environments are fully compatible, and you should be able to move them to your Amazon EKS cluster. So we have a wide ecosystem of services now that are enabling customers to build production workloads leveraging containers on AWS. So again, it's not just microservices. There's many more use cases in that space. So to go down that level of operational responsibility one step further that Mike was talking about before, right? There's this spectrum of shared responsibility. And you have your options around compute, and at the bottom there, and at the same time you have the essentially the managed services up top. So with EC2, you can build and run things, but you manage the integrations, the scaling, the security config, provisioning, patching, in addition to your code. And when you compare that to services like Lambda and Fargate, you obviously have less to manage because they're obviously managed services. But while the heavy lifting has been taken on by AWS, this means that you need to focus your efforts around thinking about the more important aspects of your application, and how can you put automation in place to test and secure and monitor the application throughout the software development lifecycle. So I like to think of it as you're essentially freeing up resources on your teams. They're now there to focus on the more important things when they're leveraging this service or these services. Your customers really don't care that, for instance, you're really good at managing a container orchestrator. They care essentially about their experience, right? So if you leverage services like Lambda or Fargate as part of your microservices implementation, you can focus on that customer experience, and you can improve the overall quality of your application instead of putting cycles towards things like provisioning and cluster scaling and patching. So we wanted to talk a little bit about the monolith versus microservices, and we'll get into an example of both in further slides. But we've seen this comparison before, right? Customers have been trying to figure out how to migrate off of their monolithic architectures, and they've naturally looked at microservices. And to my point earlier, we've also seen people take existing smaller monoliths and move them into containers as a way to get started to potentially decouple that application as they move towards the cloud, right? But one of the reasons they're trying to eliminate, or they're trying to move, is they're trying to get rid of this friction that comes with maintaining a monolith throughout that software development lifecycle. They typically have developers, and they're all pushing changes, and if they're lucky, they might have a software delivery pipeline. But regardless, it's probably shared. And they still need to go through the process of coordinating all of their changes with the other team members or other developers and engineers to make sure that their changes don't break somebody else's code, right? There's almost always shared libraries, and if you want to upgrade that shared library to take advantage of a new feature, or maybe there's a security issue, whatever it may be, you now have to kind of like convince or align everyone else at the exact same time which can be difficult. And when it comes to putting that fix or patch in, you essentially have to merge it in with everyone else's code in the monolith. You have to go through this process of compiling it and resolving conflicts, and you got to rebuild it. And then you have to run all of your test suites and start this deployment process to get it in the staging and production. It's very lengthy, right? So a very, very small change essentially sends you through this process, which isn't quicker to market, right? And that it doesn't fold into that concept we were talking about earlier. And to be honest with you, it's unacceptable. If you think about today's technology landscape, that's available today, I personally think it's a leftover artifact of legacy development cultures, right? So microservices help address this problem because each microservice is deployed separately. And because they can interact together, they achieve a broader use case, meaning they can be organized around business capability, they can be scaled independently. Each microservice that talks to another microservice is done via that published API that I was talking about earlier, and they need to provide an API themselves. The teams that are working on them are working independently, but they're also not just building it; they're deploying it and they're maintaining it. Right. So there's this concept where in this new world, the ownership is key, and every team has a service owner. And those owners are architecting and implementing and supporting and fixing things essentially in that innovation flywheel that we were talking about earlier. This was something, again, we covered in detail in the previous webinar, where we talked about the organization of the teams and that shifting in responsibility. So with that said, I want to get into a little bit of an example, and I'm going to let Mike drive this, where we talk about the old versus the new, essentially.
Yeah, great. So starting off, kind of talking about what the traditional monolithic architecture looks like. I'm sure that everyone on this call has probably built something that looks kind of similar to this. So you typically are going to have a load balancer in front with potentially multiple instances of your application running on the back end for high availability. Typically, it's often difficult to kind of use this to dynamically scale, although that does happen a little bit in these types of architectures. But the fundamental idea here is that all of these different sets of functionality are all contained inside of a single process. So typically this would be like a Java EE type application where you're running a Tomcat server and you've got a bunch of different servlets as well as potentially EJBs and all of the other backend pieces that are all working together inside of that one single Java process. And then you may deploy that across multiple servers and load balance across those, as I mentioned. But all of the different kind of interactions between these services are happening with direct kind of in-memory function calls made either to interfaces or directly to concrete classes and implementations that happen inside of there. And then everyone is talking to the same backend database. And so, as Carmen was kind of referring to previously, if you've got multiple teams now that are responsible for different pieces of this architecture, so each layer potentially has a different set of developers that are working on it, in order to release this, in order to make changes to it, in order to update the data model or anything like that, requires this massive kind of coordination across a number of different teams in order to get that change actually pushed out the door. You have issues around, introducing regressions, unintended consequences that happen from changing one part of the system end up impacting other parts that you didn't expect. And so that's oftentimes kind of the pain point that really drives a lot of this migration in the first place. So contrasting that now with a microservices version of this same architecture, if we take a look at that, you'll notice now we've split out each one of those different kind of components that was inside of that monolithic process into its own individual service. So there's a few things to note here that are important characteristics of this new architecture. The first is that, as we talked about from an organizational perspective, each one of these new boxes is owned by an individual team. Now, you might have a team that owns a few different services themselves, but one of the big keys is that you want to make sure that each one of the services that you're operating is 100% owned by a single development team, and they have full autonomy and authority to make decisions about how they're building and deploying and managing that service. Now, you may have kind of standards across your organization about certain technology choices or security policies, et cetera, that everyone adheres to. But overall, you want to make sure that the developers that are building each individual service are free to innovate and operate based on what they know is best for their own service. And then what that means is each one of these services needs to expose a standardized API for other services to interact with it. So you'll see that there's a separate load balancer in front of each one of these services. And the key there is not just that you have some load balancer that accepts requests, but that the API being exposed at the front end of those services is considered to be a contract, and that the teams that are running each of those services maintain that contract across releases. So essentially, anything that they want to do to change the code or the functionality behind the scenes is completely up to them. It's up to them to set their own release cycle, their own release cadence. There shouldn't be significant coordination across all of the different services out there, because their goal is to expose a standard API contract, and as long as they don't change that API, no one else should really care. And so that ends up being really important to really put a lot of time and effort into designing those APIs well. And then once you're actually deployed those and they've gone out into production, now you as a service team are responsible for maintaining fidelity to that API, and not introducing incompatible, backwards incompatibility into future updates of the service. The last piece that's really important to keep in mind here is that you'll notice that each one of these three services on the right side have their own database. So we're not sharing data stores anymore across services. And this is really, really critical in order, again, to enable those teams that are managing these services to be able to make changes independent of one another. So you want to make sure that if the account service team decides they want to make a change to their data model, that's not going to impact the cart service or shipping service. You want to make sure that because those changes will often have significant impacts to other kind of pieces of code. And so in order to maintain that isolation, you're going to need to ensure that that everyone is using their own kind of database. So those are kind of the really sort of critical high level features, I guess, from an architectural perspective that you should ensure you're adhering to when you go through and start building a new microservices architecture. So now let's talk. So we've talked a little bit about kind of the comparison between monoliths and microservices, but ultimately, again, keep in mind that the end goal here is really about increasing agility. It's about increasing the ability for teams to deliver new changes and fix problems more quickly than you would be able to previously. Simplifying deployment, making it easier to scale things flexibly. So when you have multiple services, there may be different sort of scaling demands. You may have some services that need to manage lots of individual small requests that take very little processing time to process each one. You may have other services that require significantly more compute power. Maybe one's very memory intensive while one's very IO intensive. And so being able to kind of scale those services independently of one another allows you to do a better job of kind of matching demand, and do so at a more cost-efficient, in a more cost-efficient manner. Now, all of these benefits that we talk about, and microservices is definitely becoming a big kind of buzzword. Everyone thinks that this is the only way to build modern applications. I think it's important to understand that with all of these benefits comes a degree of complexity, a degree of added complexity. So when we looked at that new model, it looks very pretty and simple when you draw it out on the on the whiteboard, but keep in mind that each new service that you create means that's a new process now that needs to be deployed and managed and monitored. Your teams now have additional responsibilities that they need to think about in terms of how they're managing all of those different pieces. And so to some degree, these benefits come with a certain cost, and you need to be aware of that cost that you're undertaking, and not necessarily choose to go to a microservices architecture just for the sake of doing the modern thing, Make sure that you're doing it because you actually have the problems and the pain points that we've talked about previously with monoliths. So if you have a monolithic code base, but it's still small enough that you only have a single team working on it, and that single team is able to do deployments relatively frequently, they can do a deployment after every 2-week sprint. You've got all of the pieces in place in order to make that process automated and fast and agile. You may not need to actually change over and start using a microservices architecture. There may be benefits to putting that application into a container so that you can go and deploy it more readily across a number of different environments, standardize the way that it's packaged, etc. But the architectural concept of breaking all of these pieces of functionality out and adding separate databases, putting load balancers in front of all of those, creating these contractual APIs, it's not always worth the additional complexity in order to get these benefits if you already are seeing these kind of benefits with your current code base. So I think there are definitely times when customers jump the gun a little bit, to be honest, in trying to adopt microservices for systems that were working just fine previously. That being said, obviously there are a number of times when certainly the benefits well outweigh the cost. And I think in general, moving to that model where you can get a single team owning a single piece of code is really kind of the key there. So if you're doing that and it feels like you're still managing a monolith, that might be okay, if you're still operating that model, because to a certain extent, you've already got a microservices organizational unit, if you will, if you've got a small team owning a single service with those components. So yeah, so looking at this now, so assuming that you have decided we're going to make the jump, we're going to move to building, refactoring this particular system, or we're building something from scratch and we want to use a microservices architecture. What are the things that we oftentimes see people get tripped up on? And what are the practices and ways of mitigating those risks? That's really what we want to spend the second half of this talk discussing. So a few of the things that oftentimes come up when we see people starting down this road is, small changes taking a long time to release. So continuing to live in this pain of, hey, we're trying to move more quickly, yet we find that it's very difficult for us to get code changes all the way pushed into production, right? So talking about releases, a lot of times customers can get it out into the dev environment or into their test environment pretty quickly. But then there's a lot of additional sort of steps that it might take before things actually get to production, which is what we really care about, is how fast can you get out to production. Also, this idea that now you've got a bunch of different services, so we've got significantly more processes than we used to in order to accomplish the same kind of functional scope. So being able to understand kind of where are all of our deployments at, what are all of these pieces, where do they all exist, is an important kind of question to be able to answer. Similarly, the security process, integrating their existing AppSec review process into this new microservices environment can definitely be a challenge. And then similarly, the idea of being able to monitor these things and gain visibility into a world where you no longer have a single stack trace when something goes wrong. In the monolithic world, it's great because I get an error log and I can kind of see the entire stack trace through the entire system. It's all contained in a single process. All of my logs are in one place. But now in a microservices world, you might have a case where you've got a dozen different processes that all touched this one request before it actually got filled. And so tracking down where the problems are can definitely be more complicated. And then finally, ensuring that they've got good fidelity across all of the different environments that they're using. So again, you're going to be doing a lot more releases. There's a lot more processes now that are getting moved through these various environments, and ensuring that all of that stuff works consistently across all of those processes is one of the kind of big keys to being successful in an area where people sometimes get tripped up. So in order to talk about kind of how we can address each of these issues, we're going to walk through a couple of different sort of high-level best practices. So unfortunately, given the amount of time that we have today, each one of these topics could probably fill a day-long deep dive workshop. So we're really just going to be touching on some sort of high level concepts that we would encourage you to use as jumping off points. But we did want to talk through a few of the sort of common best practices that we see for customers who are getting started with microservices in order to make sure that they're kind of successful. So I'll hand it over to Carmen to kick us off with our first practice.
Yeah. So the first thing that you need to think about is CI/CD, right? You're not going to succeed unless you get this component in place and you get it in place correctly. CI/CD, for those who are unfamiliar with it, hopefully you are familiar with it, but it stands for continuous integration, continuous deployment. And to my point before, if you're going to modernize your applications, you need to bring a CI/CD and DevOps practice into your application lifecycle. So incorporating automation, bringing that cultural component of learning how to integrate frequently. Customers are able to find and address their bugs quicker. They improve their overall software quality, and they reduce the time it takes to validate and release new software updates. I just want to briefly just talk about the various different concepts, if you will, because to be honest with you, I see individuals getting confused even at this level, right? So continuous integration, what is that? So continuous integration is a development practice where developers are integrating code into a shared code repository or a central branch multiple times a day. Every one of your check-ins is essentially then verified via an automated build and a testing process that allows your development teams to get this feedback and detect problems very, very early in the cycle, right? And this is a way for them to avoid conflicts in the future. Continuous delivery is an approach where your development teams are working on these small sprints or small chunks or features in each sprint. And the goal is to ensure that the software can be released at any single time in a deployable state. It's essentially expanding on that continuous integration model by deploying all of the code changes to a testing environment. And then from there, going to a production environment after your testing. And the tests go beyond the unit tests. And you typically see in continuous integration things like load testing or integration testing or UI testing and many, many more. But every code change is built, tested, and then pushed to a non-prod environment for further testing, right? And along the way, there can be all of these multiple parallel stages before production deployment. And once your test is finally passed, there's this approval stage before the update to production. Continuous deployment, the last one, is essentially the same as what I just mentioned with the continuous delivery, but the production changes happen automatically without explicit approval. And the emphasis is essentially you need to think about tests even more in your workflow. You need to think about what kind of tests you need to run before you cut over your users. So it requires, this significant effort on your team's part to make sure that before you press that magic button, that all services are working essentially, as needed for your customers to have a great experience on your platform. If you want to look and get started, again, to Mike's point, there's so much material out for this. Check out the reInvent videos or some of just the landing pages on the AWS site, and you can learn about how you can do things with like code commit and code build, code deploy, code pipeline just to get started. You can take advantage of serverless solutions like Lambda, or even leverage CI/CD, with containers as part of your workflows. So definitely go check that out. But that's one of the first pillars. The second pillar that we think is super, super important that you need to think about is monitoring. And when you get into microservices, how are you going to monitor these architectures? Because essentially it's not the same as when you were monitoring a monolithic application. Those, to Mike's point, they were deployed as a single executable. And compared to microservices, there's all these independent services inside your environment. And each service has its own function, and the collective group of those microservices make up your application. And at each level, the service in itself can have a series of dependencies, like, as Mike's point before, like each one has its own database. And each one of those is something that could potentially fail and needs to be considered as part of your overall monitoring strategy. So you need to ask yourself, how can you architect your application that if a dependent component of a microservice fails or goes into this degraded state, can you detect those problems easily? So when thinking about microservices and monitoring, a good place to start is metrics, right? Your application metrics could be considered your first tier of things to think about. And this is where you gather all the data that's useful for your teams to understand the overall health of your system. And it's important to think about, your application logs and how you're going to publish and consume them as you design your microservices. If you follow 12-factor application methodology, you'll understand that logs should be loosely coupled from the system. You would never try and write or manage those files to disks, because those essentially, if it was a container, it's immutable, right? It can go away at any moment. It's best practice to emit those logs to a stream. So again, in like a container, you're gonna log the standard out, you're gonna log the standard error, and you're gonna aggregate them someplace else. Maybe you're using CloudWatch to do that for further analysis. Platform metrics is another tier, or events is another tier, and you think of this as your infrastructure. Maybe you're looking at the underlying cloud platform. You're looking at AWS as a whole and all the services you're consuming. Maybe it's the billing events or network traces inside of your account, or maybe it's the API calls that you're seeing inside of CloudTrail. That's what I like to call the platform metrics and events. The last one is the system events. So if you think about this, this is the ability to understand deployments, but also a couple other things. We'll get into that. But being able to correlate a software release and log these events back to the behavior of the system, right? How are essentially maybe operational changes and scaling events and config updates going to be alerted on and gathered? And if you think about it, if you're doing everything, via DevOps or infrastructure as code, mindset, config updates and operational changes should never be done by hand. They should be part of the software release process. So they should be, essentially, gathered and tagged appropriately as they flow through your CI/CD system. And we talk about, lastly, this distributed tracing model. And if you think about it, in many cases, this microservices, there's multiple pieces working together to handle a request. So in this complex system where you have tens of microservices, maybe an error occurs somewhere inside of that chain, every one of your systems needs to be logging properly, and the logs should be consolidated into the central system. But it's hard to find the relevant messages, right? This is where something like X-Ray, AWS X-Ray, could essentially come in and help you out, because you'll be able to see and visualize the end-to-end view of your requests as they travel through your application, and you start to get that flow using the correlation IDs in your event chain. So to go a little bit deeper, because monitoring is super important, right? We talk to customers about the concepts of this centralized log strategy. And when you're planning this, you need to identify your requirements, whether they be compliance or business. How are you going to essentially, do access control? What's the aggregation model going to look like? What are you going to retain on? Like, how long are you going to retain the logs? And you need to find a solution that, again, can support, all of these use cases as you expand into AWS and you take advantage of more and more services inside of AWS. This slide shows you a couple of things to think about, but I want to highlight a couple of more. So logging essentially via all environments, like in my opinion, that's a no-brainer. With that said, your application should always be configurable. So as you traverse from environment to environment, you should be able to set different log levels for deeper troubleshooting when needed. You do need to think about an SLA and automated response times. So that's another thing to think about. So think about like synthetic transaction monitoring, like I was talking about before, that end to end. Like, how do I get started? How am I going to actually aggregate those? What's going to send those out? Maybe you can actually start simple and build that with something like Lambda, like a simple little synthetic transaction monitor that calls some URLs inside of your application and reports back, right? Another one is essentially your log retention requirements. How long are you going to keep them? Meaning, like, are you going to set lifecycle policies? What's essentially the plan to move those off? Where are they going to go? Maybe you move those over to something that's cost effective, like Glacier, right? And then at the same time too, like, you want to incorporate the tools and features that help you enforce lifecycle policies. So again, like maybe you're using Amazon S3. It's cost effective. It's an easy place to put your logs, and it has built-in lifecycle capabilities. And at the same time too, maybe you're using CloudWatch logs. Things like Lambda, they natively ship their logs out to output into CloudWatch logs. So does ECS, right? So, using in ECS, the AWS logs driver, as part of your task definition, allows you to take those container logs and put them in a centralized place. So I think the point I'm trying to make here is when you're thinking about where to store them is like before maybe you go down the wormhole of building your own custom built solution, maybe you're going to do like your own open source elk stack or something like that. Think about all the things that you need to do in terms of maintaining that, and maybe again start with something that's pre-built and try and leverage that as part of your workflow. So because to my point earlier, customers don't care that you're really good at gathering your logs, right? They care about the user experience. So how can you actually make the user experience easier for them while taking away some of the operational responsibilities that you take on as you build your applications, right? So maybe you look to some of these managed services as part of your implementation. Security is something else that's paramount. And in any organization, you need to think about all of the attack areas of a microservice-based architecture and how you're going to protect and audit around them. Again, another one that we could spend so much time on here, but like the one that I want to kind of jump on is security scanning. You have all of these microservices inside your environment. Think of how you're going to achieve vulnerability and how you're going to do security scanning within maybe your container or Lambda functions. Perhaps your application is dependent on an external package, and maybe you're inheriting from this base container image, and then maybe you're rolling your own image in your environment. But how do you know that the components you're dependent on aren't vulnerable? And in the case of runtime monitoring, what about the functions and containers that are already running in your environment? If a critical security release comes out for a particular package, like how are you auditing on it? These are things, again, that you can go super, super deep on. We could spend a lot of time on, but I just want to get your head around essentially how important that is, right? And the incidence response is another super key topic here because, if you think about the flow, it's like this. You establish control when an incident happens. You're trying to determine the impact. Maybe you're going through this recovery stage. Then you get into the investigative stage where you're trying to figure out the root cause, and you're trying to improve. And you have to realize the importance of monitoring and metrics when tied to security and incident response because of the scale you could be operating at in a large microservices implementation. To Mike's point, where it can become hard. So you need to think about, and you have to realize the importance of having an incident response plan so your teams know, how are they doing the right thing, or are they doing the right thing? And obviously, having people following procedural steps is a path towards error. Because if they miss a step, this is why you want to start looking into automating like these mundane tasks as part of this incident response process, and have potentially automated redeployment or remediation mechanisms to help improve your process. And then finally, organizations should test this process by essentially running incident response game days or security simulations. And if you haven't run those, incident response game days are essentially exercises that allow the security and operational teams, or your pizza teams, understand how the organization would respond if an event occurred inside of your environment. So we talked about this a lot in the last webinar as well. I'll just briefly chat on this one, but you need to think about security way earlier in the process. It's now everyone's job. It's part of the planning phase. It's not just your security teams. It's moving over. Your developers now have a role in security. They need to understand that it's not about building and shipping the application and handing it off to another team to implement security components and controls. Everyone has the stake, and it needs to be factored into all decisions that are made about how an application are built, how they're tested, and how they're deployed. So, we talked a lot about shift left in the prior webinar. So I would definitely suggest you go check that out, because again, that's a super important stage as part of, building applications in this new world. Mike's going to talk about the other two pillars, and I'm going to pass it over to him.
Great, thanks a lot, Carmen. So the next pillar, or next practice, I think that's important to think about is how you're managing applications and services. So typically when you're building cloud native microservices, there's going to be a number of different components that are involved in actually deploying one of these. So that may take the form of having multiple Lambda functions, as well as things like queues and databases or other resources within AWS, or maybe this is multiple containers or tasks or services that are running on top of something like ECS. So whatever kind of underlying technology you're using, you need a way of being able to reason about sort of these services and all of the different components that comprise each individual application as a holistic unit. So this typically takes the form of either a CloudFormation template or something like a SAM template. So SAM stands for the serverless application model, which is an extension to CloudFormation. So this allows you to define a single declarative template that defines how your application is built and deployed. And then you can use CloudFormation now to deploy to any environment, so to your dev, test, or prod environment in a single repeatable process. If you're using something like Kubernetes, say, you might use something like Helm to define all of the different containers and processes there. Or if you're using ECS, again, something like CloudFormation to define all of your tasks and services in a single place and orchestrate kind of that deployment would be another thing. But again, just make sure that you're thinking about how are we kind of defining all of these different components and integrating that into a way that we can easily coordinate that across all of our different environments. So the next practice is about IDEs and developer tools. So this is kind of the last one that we're discussing here, but I think the key to this is ensuring that you have the tooling in place for your teams to be able to repeatably validate the functionality of the services you're building locally in your own development environment so that they run the same way that they do in the cloud. Now, the approach that you use for this, again, is going to depend a little bit on what technologies you're using. So if you're going serverless, if you're using something like Lambda, using SAM or the serverless application model is a great mechanism for this. So SAM gives you the ability to invoke things locally and debug functions from your own IDE. Versus if you're using more of a containerized approach, then you're probably going to be running Docker on your local development environments and debugging things directly there. Another aspect of this to think about is, this concept that we call cloud side development. So I think very often, people have had this mindset for years that I should be able to run my IDE, my development environment, without any kind of internet connection, right? If I'm on an airplane and I don't want to pay for Wi-Fi, I should still be able to run my entire stack locally on my laptop. I think that kind of mindset is starting to break down a little bit as we move to this more kind of distributed microservices architecture. I don't think it's always realistic to think that you're going to be able to set everything up to run on your own laptop. And we've got a lot of customers and a lot of teams internal to Amazon that have moved away from this idea and actually consume real live cloud resources as part of their local development test suite. So if you're using something like DynamoDB to back a service, you don't have to use DynamoDB local as part of your test suite. It's okay to actually create a real live DynamoDB table in a developer isolated account and then connect to that as part of the test suite. So even the code is running locally in your development environment, you're actually connecting to these other resources that are kind of remote. So to kind of sum up everything that we've talked about a number of different sort of practices, everything from CI/CD, having these automated pipelines that allow you to very repeatably deploy your code and get it all the way through to production. Changes in the way that you think about monitoring and observing your code so that you can consolidate this across all of these different services, integrating security through the entire lifecycle of your application, using services and tools so that you can manage applications holistically. And then the last is really making sure that you've got that standardized local development environment that you can use to repeatably build and test your application locally. And so these steps, again, just kind of tying this back, are really what we see as the foundational components to be able to address the big challenges that we looked at the beginning. So if we take a look at the next slide here about kind of these issues that we looked at initially. So small code changes, having difficulty getting those pushed all the way to production. Automating that pipeline with CI/CD is going to be a critical step in kind of resolving that. Having issues around kind of manual deployment. So again, CI/CD, in addition to using these kind of application frameworks or having definitions and deployment mechanisms that wrap around your entire system is the sort of important key there. Integrating your application security review process throughout the entire pipeline and automating as much of that as possible ends up becoming a really critical step, and really kind of getting, from an organizational perspective, getting the security team on board with this idea, getting them integrated into that process early. The visibility issue, and really kind of having a strategic approach to how you're monitoring and observing these different functions or these different services, ensuring that they're all contributing data about the operational characteristics, about their errors and things like that, into a centralized system where you can see everything and get a full view end to end. And then finally, again, getting back to this idea of having automation and deployment mechanisms that span across everything from your local environment through to production, and standardizing on the way that you're managing that so that you can get very consistent kind of results across all of your different, across all of the different environments that you're working in, again, is something that's important. It's something that you should be investing in and thinking about from the very beginning. So just as kind of a next step, taking a look at sort of where do you go kind of next? Well, there are a wide variety of services out there available from both AWS as well as all of our partners that can help you address each of these different kind of issues. Again, like we said, each one of the different practices that we talked about can be expanded on at length. And so there's a lot of great content out there that deep dives in each one of these different services, as well as each of the different practices we talked about, and how you can leverage these kind of different services and different partner tools. But I would encourage you to take a look at what's available, what can you offload, again, to your cloud provider, to other service providers, so that you can focus on just building the differentiated business functionality that matters to your customers. So the kind of last note that I wanted to make is, thinking about this again, getting all the way back to the original point that we made about innovation and experimentation. At the end of the day, the architectural concepts and the technical details about how you actually go about building specific microservices is great, but you always need to make sure that you're focused on how do we innovate faster? How do we free developers in order to do those kinds of experiments and fail without fear? I think at the end of the day, that's really the underlying justification for why we're making these technical shifts. And I think it's really important to kind of keep that top of mind as you go through this journey. So with that said, that's all of the content that we have prepared for today. We really appreciate your time and attention today. And I will turn it over to Carmen to talk a little bit about our partners.
Yeah, awesome. So just really quick to wrap it up, and my apologies to those who hung on today, because we're running a little short on time, and we're definitely going to follow up with each one of you individually for your Q&A. We're not going to let those go into the ether. But you can see this is a very wide topic, and it can take quite a bit of time just to even go over it at a high level. So thank you for sticking with us. But to close it out, I just want to highlight our partners as well, because they play a super important role in helping you as a customer achieve success, right? So right here we have Slalom, who essentially is one of our consulting partners, and they can help you in this space and realize this reduced time to market when building microservices for your applications on top of AWS. They're not obviously the only consulting partner out there. We have many, many more. We chose them because, again, they have multiple competencies in this space, but there's many other consulting partners out there that you can find on our consulting partner competency page that also hold these competencies that can help you. So if you want to check that out, you can learn a little bit more about them. And we also have our ISV partners, right? At the end of the day, the competency program has categories for both, and they help their customers migrate, build, and run applications and infrastructure on AWS. And the competency is intended to highlight these partners who help you as the customer with their workloads while taking advantage of things like security and architectural best practices. It's meant to be a clear recommendation for you to essentially pick the partner that helps you achieve success and offer a low-risk path to achieve that success on AWS. So the bar is extremely high. We only admit partners with a proven track record in essentially enabling customers and have the sufficient skilled personnel to perform multiple significant projects. Thank you again for attending today's webinar and staying with us. We did go a little bit long, and I apologize there. If you do have any other questions, feel free to reach out to us. Again, these webinars will be on demand. So thanks again for your time, and have a great one.